All of these sessions are uploaded on YouTube. I use YouTube as a file sharing service. So you will have links. If you want to download the videos, you just use video downloader. As long as I'm asked, you have my permission. I don't think that YouTube is going to ask my permission. I don't know what the legal rights are, but they're publicly available, open access on the internet. This is going to be the final lecture. After finishing this lecture, I will upload it instantly into YouTube, and you will be able to get it from there. Now, I hope you have scanned this barcode overview because I can start with the slides. I'm going to try with this maximizing the window. Whoever sits opposite me, if you hear me talking about specific standard and it's not showing on this web page, let me know, because what happens is when I open Google now, Google is open, it's not showing. It's something I have to figure it out, but that's going to be something tasks to do in the future. In this session, we're going to be talking about SBOMs and AIBOMs, and this is probably the most relevant. You can keep the door open, so other people can come in. Keep it open for 5 minutes. This session is probably the most relevant session to people that work in law and administration, because now we're going to talk how do you manage all the risks that we discussed in the previous 4 sessions. So just as a reminder, we started with a session on AI fundamentals. What are the risks from AI in general? Then we went to quantum computers, the risk from quantum computers. Then we went to blockchain security, the benefits and the risk of blockchain. Yesterday we spoke about agentic AI versus normal AI. And today we're going to talk about how do you risk manage, how do you regulate, how do you make all of those technologies transparent. And there's always easy solution, just that people are not always prepared to accept it. It's up to you, as I said from the beginning, for the purpose of this class, whatever previous knowledge you have about AI security, you put it in a box and you keep it by the door, so when we finish the sessions you can take your box and your old opinions with you. At the end of this session you can pick up your box. I'm not going to try to influence your opinion to say this is the best way to manage and to secure AI. What I'm going to say is from a technical perspective, we're looking at how do we implement these regulations. It's not a regulator would come and say you need to do X, Y, Z. My question is how? How do I do X, Y, Z? I don't know how to do that. So this is the slide, the session when we talk how do you secure agentic AI when you have 1,000 AI agents, each one is performing autonomous functions, and you have no visibility over what agent 365 or 367 is doing. You simply don't have any visibility over that. How do you risk manage that? So that's the purpose of today's session. I'm going to go through the slide quickly. And let me just check the time now. By the way, I'm looking at the time. This session should finish at 12:15. I'm going to make a note, and if I forget, please remind me. Around 10 minutes before 12, I need to wrap this up. So the session on AI Bill of Materials needs to end around 10 minutes to 12. Then we need to review what did we discuss in the previous sessions, and I want to give you time for questions and answers, because I'm going to have to end the session on time to give you your lunch break, but also to prepare for my next session, which is going to be a very short session. Then I'll go to the hotel and I'll continue with my next sessions. But I don't have enough time to walk from here to the hotel between this session and the next session. That's why I'm going to have my next session in this room. I don't mind if you stay, I don't mind people, just that other people would be watching because there's going to be a different class. Be mindful of that, that if you stay in this group, in this room after the end of this session, I will start recording for a different session and you might be floating in the background. But I'll finish before you come back for lunch. Now, looking at, this is me, looking at understanding SBOM and AIBOMs. I do have at the end easy instruments that even you can use without any technical knowledge. So by the end of this session, you're going to be able to create a complete map. Remember yesterday I showed you on Hugging Face 2.5 million models, 700,000 data sets. By the end of this session, you're going to be able to assess those data sets if they have any malicious files inside. Every time you make something so simple, you eliminate the details and then you open yourself up for criticism. If you understand 95% of how do you assess this, for me that's a success. because at this present moment, nobody in this group knows how to download those datasets from Hugging Face and how to scan them for vulnerabilities. You just don't. I asked you questions and you didn't know how to answer them. So if by the end of this session you have 95% of the knowledge of how to assess those datasets at a speed, I consider that a success. And then when you have a discussion or when you watch YouTube or when you attend another lecture, you say, oh, well, he didn't mention this. You cannot mention everything in a single class. So I hope you're understanding that part, that some people are working on this their entire lives and they still don't know how to do it properly. There's going to be still something that remains. Another thing, just to build upon that, is that every time people come to Oxford, like students from Netherlands, from Germany, they're very surprised that Oxford professors, doctors, PhDs, they're very, very specialized and they know very little about other subjects. So, for example, I have a friend from the Netherlands, he said, I'm shocked. These people, they know only what they know. They don't know anything else. They don't know politics, they don't know the names of the politicians, they don't know who is Kardashians. I personally, I know the name Kardashians, I don't know the names of who are the Kardashians, because I have to invest all my time on this in order to be an expert. So it's difficult. Once we have a chip that we can connect different brains, I will be able to transfer that information at speed, but it's difficult to compress 20 years of knowledge in one session. So what is an SBOM, Software Bill of Material? Software bill of material, it's a breakdown of the components that they exist in any software. Most of the software that you're using, between 85 and 95%, it's actually taken from open source software. So there is no restrictions on that software. The difficulty is that we don't know what component comes from where. Why? Because of proprietary information. So when you build software, you want to sell it for 3 million. Sometimes you don't want to disclose that 85-95% of that software is actually publicly available in open source GitHub repositories. Well, in 2021, Joe Biden, now you won't be able to find it on the internet because Donald Trump doesn't like Joe Biden, so they have taken this. But Joe Biden made an executive order which said that SBOMs are compulsory requirements in the United States. That's the US regulation. You cannot produce software and sell it to the feds unless you have an SBOM. Now, you would think Donald Trump would change that and next governments would change that. They didn't. Basically, they deleted the note that Joe Biden made the executive order and they made it Donald Trump. So Donald Trump is very much behind it. This continues. It's not stopping. Another interesting thing about software bill of material, and I will show you, I will demonstrate how you can do it. If you have a GitHub, you can follow the steps, you will do the same. You would learn how to do it on this session. So if you have a computer, please log in. If you have a GitHub, log into your GitHub, you will be able to do the steps that I'm doing, how to create an SBOM. In 2021, it was very difficult. Nobody knew how to build this. It's been 5 years since then. We have automated the process. It took us 5 years. Now we have a process how you can automatically generate software bills of materials. Now, what is a bill of material? Does anybody has any food product here? Maybe that's bottle. Do you mind turning that bottle on the back? So people would say the small print. No, just the small print on the back. Can I? You see, every product that you buy contains a bill of material. This is a bill of material. It doesn't actually tell you the recipe of how to produce this product. Therefore, it's not infringing intellectual property. It just tells you what components are in this. So from a risk perspective, why is that important? If you have allergies for peanuts or for specific, you look at this bill of material here, you read it, well, this is on Chinese, so I want you to be able to read it. But you read if there's peanuts in that, and if there is no peanuts, then you drink it. If there is peanuts, you obviously won't drink it. That's why an SBOM is. It's a bill of material, but it's specific for software. Now, before we transition into AI bill of materials, let me demonstrate how you can create a software bill of materials. And again, I'm going to start from scratch. I have not prepared for this. I'm going to show you the steps that you need to do and how to find them. So you go first to a browser. Let's say you go to Google and you type SBOM GitHub. Exporting software bill of material for your own repository. Let me open some tools here. And here you have a screenshot. Hold on, why not? Did you follow the steps of how this was done? If you need to do it tomorrow, do you know how to do it? Because at the end of this session, if you don't know how to create an SBOM, I'm going to be very disappointed in you. If you spend the entire class sleeping, I don't mind. If you spend the entire class playing video game, I don't mind. There's going to be 2 or 3 sections in this session that I really want you to pay attention. This is one of them, because now we're doing practical. If tomorrow somebody asks you to produce an SBOM, you need to be able to do it. And if you don't follow this, you won't be able to do it. So what did I do now? I went to Google. Hold on, let me change this up. So I just typed SBOM GitHub in Google browser, any browser. And the first link that came up was exporting bill of material. Now if you look this on Edge, if you use this Safari or different browsers, Firefox, it might not show up as the very first link, might be the second, the third, doesn't matter. This is the link that you're looking for, exporting a bill of materials. Now I'm gonna log into my GitHub. I'm not even logged into my GitHub, so I'm gonna log into my GitHub and I will show you how to do that. I hope it's not gonna ask me for any further, no, it didn't, okay. By the way, if you do see different faces, different names, I'm a pen tester, I'm a penetration tester, and quite often I do get blocked, therefore I have to create this. It's artificial intelligence. This image does not belong to a human. So this is my GitHub repository. Here I have multiple repositories. You follow the steps because you're not going to remember this. So you go to the screenshot here and you follow those steps. Now since I know how to do it, I don't have to read that. I'm just going to go to a repository, any repository. This is my repository for the course on AI malware. And then I need to go into Insights here. And if you look at the screenshots, it will tell you that, you see, Insights. That's the screenshot from the description. How do you create an SBOM? That's what we're doing now. So Insights, and here on the Insights, you need to go to dependency graph. Dependency graph. No dependencies found. Look at this here. Export an SBOM. That is how simple we have made it over the last 5 years. So if you are not interested in being compliant with the US law, that is on you. But the steps are very simple. It's not the same with the European Union AI Act. There's no button. Nobody is actually building a button for us to be compliant with the European Union AI Act. Now, if you don't click on that button, Export SBOM, that means that maybe you didn't upload your code into an online repository like GitHub, so GitHub cannot create the SBOM for you. Maybe you want to hide your code. Maybe you have various reasons why you don't want to produce an SBOM to make your software transparent. But it's not an excuse that you don't have the knowledge. You see, you have never done this before. By the end of this session, you're going to know how to export an SBOM. So I'm going to click the button. And I'm going to go a little bit further, actually. I'm going to show. So you see here in my downloads, a file was downloaded. It's going to be JSON file format. So this is a JSON file format. Now it's being opened with Firefox. Obviously, you can open the same JSON file. You can open it with VS Code. You can open it with any coding environment. And in Firefox, you can actually open it in browser. So you can use Google Colab. There's many ways how you can open this. So this is what the software looks like. If you go into the components, it tells you when it was created, and it gives you quite a lot of details that maybe for you they don't mean anything, but they mean a lot to the computer. This is a JSON file, means machine readable. A machine can read this. Is this the only and is this the best format for SBOM? No. You have many other formats that you can create an SBOM. So if you look at this description here, you see this SPDX dependency submission, SBOM action, SBOM dependency submission furthermore. And it tells you, hold on, let me highlight this. SIFT, it's automated tool that you can connect to the National Vulnerability Database where all the vulnerabilities are stored. So once you download the SBOM, which is, hold on, which is this, we just did it. Once you download that file, you can use SIFT. That's beyond the scope of one class, because not because it's difficult, because it takes time. But I do have videos on my YouTube channel how to do the steps for SIFT. It's very simple. Once you connect SIFT to your GitHub repository, you can give the coding environment, the API to the National Vulnerability Database. The Americans are giving that for free. You don't have to pay anything for it. So you can connect to the National Vulnerability Database, and you can scan for, yesterday I showed you CVEs, 300,000+ CVEs. Those are only in the National Vulnerability Database. Let me remind you just, and let me show you how you can find, so CVE database, common vulnerabilities and exposures. Here you're going to have 312,000 vulnerabilities and exposures. That's in a database. The database is not CV, it's a National Vulnerability Database. NVD API. Not API, not AIB. So vulnerability APIs, they would simply ask you to register to get the API. And why do they ask you to register? Not because they're going to check if you're a hacker or if you're not. They just want to prevent automation of access to this database. Because if you can automate it, that means that you can have 1 trillion bots accessing this database, and that will block the database. You won't be able to access the database. So that is the only reason that they're asking you to register. There's no other reason that, as far as I'm aware. And once you register here, they will send you the API. And with the API, actually here they have more. You see the CVEs on this vulnerability database, it's 329,728. And here we have 312. Why is this? And can somebody guess why do you have differences in vulnerabilities? No? No guesses? Many of these vulnerabilities are no longer considered threats. So if they are listed or if they are not listed, Accenture has its own database. Now, I have to be careful because this is on camera and I don't want to criticize companies, I don't want to get a legal case against me. Let's say there's many companies that they have databases that they will give you subscription, they will ask you for money. It's all about money, you have to pay money. And then they would say, oh, you see on this vulnerability database you have 312,000, in our vulnerability database we're gonna have 329, that's where we are more comprehensive. This one is free. The US federal government is paying for this National Vulnerability Database. This is the database that everybody uses. And I think it's somewhere in my slides that I'm showing that this year, last year actually, 2025, the feds almost cut the funding. So they almost stopped this. It was like 1 week away from canceling the money for this. Why? Why is the European Union not paying for this? Why is India not paying for a National Vulnerability Database, making it open access for the entire world to use? Why is Australia not paying? Because it's money. Somebody has to pay that money. Now, if you go for Accenture and you use that, you're basically paying for a subscription that the feds have already paid for. They're not happy about paying for something individually. And that's perfectly reasonable. In the future, we need to have a business plan where each country would contribute towards this. European Union was not even registered as organizations that can create advisories until 2024. So that's how there's a strong voices about individual databases, but you're replicating the wheel. You're creating an in parallel database to this one. It's not going to be different. Vulnerabilities, they won't change. There's going to be the same vulnerabilities, same database, just that you're going to be paying twice money. And so far, nobody's been paying, only the US. They're not happy about that. In the future, they might stop the funding. But so far, it's free. So you can get this and you can connect with SIFT, which we said here. With SIFT, you can connect, you can create SBOMs, you can analyze them on the National Vulnerability Database. If you're not doing that, question is why? Why you're not doing something that has been made so easy for you to check? Now we covered SBOM. The next one is going to be AIBOM. AIBOM, it's a more recent effort. So before we even go to the slides, what would be the difference between a software bill of material and an AI bill of material. What is different? AI is software. So what is the difference between software and AI version of software? I'm sure somebody knows the answer. And if you don't know the answer, I'm gonna have to go back to what is AI and machine learning. I'm just looking for an image. This is the image how usually artificial intelligence is presented. Let me try to zoom. No, I don't want.
Software need inputs.
Yes, the data. This is very blurry. Let me find. Okay. So I'm looking for an image basically. That's what I'm looking for. And now I'm trying to zoom. For some reason, it doesn't want to zoom. There we are. By the way, legal thing, if you're teaching and if you take an image like this and you show it in browser, completely legal, perfectly okay, because you're showing the image directly from the source. If you take a screenshot, so if I did this, you see I'm using Apple Mac, and if I do this, I'm taking a screenshot, and if I go to my desktop now, and if I open this, if I show you that as an image for teaching, no allowed. No allowed. I can get with a legal case against me for doing that because I'm using somebody else's work. But since this is on the actual web page, if you zoom in, if you can bypass that little inconvenience that students will have to look at things over here, then it's okay. So we said machine, what is the difference between an SBOM and an AIBOM? This is artificial intelligence, it's usually described as machine learning. It's not. It's a wrong interpretation. So here you need to have another circle, symbolic AI. So artificial intelligence is basically intelligence which is artificial. Machine learning is just one type of artificial intelligence, and all the different neural nets and deep learning, they belong to the machine learning. They require data. If there is no data, it doesn't work. If you have machine learning algorithm with no data, it's like having a calculator and no numbers to input. One example that I used in China is that if you have a new variant of COVID, and if it's a new thing, we don't have data, machine learning is not going to help. You need to first collect data about a subject and then feed the data to the machine to learn. So what's the difference between software and AI now? I'm asking you the question again. Software does not always require data, right? If you're building a program, you don't need data to train the program. You just write code, but that is code. Application, you build an app on how to use yada yada yada. It's not necessary to have data fed into it. Weather app requires data in order to show you what is the weather. But when you're building the app, you don't need to have the data. The data can be connected later with the macro. There are many apps that you use on your phone that they're not actually using data at all. Compass, the compass is not, you don't need data to train a compass, and you have a compass. Radio, listening to radio. I don't really have good examples to tell you, but here when we talk about artificial intelligence, machine learning is only one. That's the one that we use. It requires data. What's the difference between an SBOM and AIBOM? AIBOM requires transparency on the data. What data did you use to train that model? That is the difference. That's the, if you ever come across SBOM and AIBOM and you don't know what's the difference, data provenance. If you don't have that, it's difficult to call it AI bill of material. Going back to the slides here. If you do want to read more about that, I'll show you my most recent paper on this, which came out last week actually. So hold on, let me find the paper. This is from, there we are. And this is from 21st of January, published 21st of January. How do you operationalize? How do you make this operational? I'm gonna go back to the slides here. It's 11 minutes past 11. I'm careful with time today. So what would you use SBOM and AIBOM for? I will have demonstrate AIBOM how to build them in future slides. So I don't want to cover the entire session in one slide. But in the next slides, I do have a demo for AI bill of material, how to build an AI bill of material. You know how to build an SBOM, you're gonna know how to build an AI bill of material. You need to be able to integrate this with existing ISO standards, because there's no point knowing how to make AI transparent and not be compliant. Compliance is going to be compulsory. This is going to be used for auditing and for legal defenses. So you would say, I have used this accredited tool to build an SBOM. I have used this, I have analyzed it against the vulnerability databases. I have done my homework. And that's probably going to be sufficient for the European Union AI Act. We don't really know yet, because when they say make your AI transparent, which AI? The one that I'm going to develop in the future, the one that I developed in the past? Do you want all the data that I used? I don't even have all the data that I used. I didn't really check all the data because it was not required back then. So is it required now to backdate and go? Those are many questions that will become more clear as soon as the European Union AI Act becomes into force, and lawyers like you will start debating this in the Parliament, in the European Parliament. Next slide here. We're moving from self-attestation to verifiable control. This is not going to be easy for software developers. So far, if I'm a developer, I'm doing the developing the attestations. But now you're going to have to make this transparent, and you're going to have to make your software transparent in the way that other people would verify it. What's the problem with this? Well, we already have cases when AI has been stolen, intellectual property has been stolen. It doesn't mean that if you have a black box algorithm that somebody else cannot steal it. They still can steal it, but it's less chances than if you make it a white box. If you make a white box, that means you're making it publicly available. Like the transformer architecture was made publicly available. The very next year, OpenAI had their own version. So as soon as you make your software, your intellectual property transparent, you don't actually control what legal mechanisms other companies will do in order to extract that knowledge. So drivers for this are European Union AI Act, NIS2, we mentioned NIS2, and DORA, but not the DORA that we use for academic scans, DORA for cryptographic, it's a different DORA framework. Now, on this slide, and most people in the European Union will tell you that the reason why we're building SBOMs and AIBOMs are to satisfy the European Union AI Act requirement, because somebody came with the regulation. That's not the case. That's not the case. SBOM came before AI bill of material. So the Americans were working on how do you make the software transparent before the European Union came up with all these very strict regulations. Just that the difference is, well, even if you go to China, who do you think is developing the most SBOMs now? China, not US, not the European Union, because the developers have seen value in this. What is the value? I'll tell you about the project. I'm standing up just to see how many of you are sleeping. If you're sleeping, I speed up the thing. I worked in Oxford for a number of years in the office with people like you, and they worked on SK, it's the Square Kilometer Array. It's a satellite up in the space, and we're going to communicate with aliens, yada yada yada. A very popular project, but people didn't stay for long on that project. Why? Because maybe they didn't like the management, maybe they didn't like the project. Actually, the reason was that they didn't really get to publish as many papers as you need in order to progress with your academic career. If you work on a development project and you work in academia, you're kind of in between two worlds. Development is in industry, you work for a company, then you're a good developer, you get paid tons of money, or if you work in academia, you publish papers. You develop small things, you publish them. And in that project, there was no development work that was publishing. So these people kept leaving everywhere. The office kept changing. Staff, software developer, who spent 2 months, gone. Another person comes in. Every time a new person would come in, I knew more about the work than they, and I didn't work on SKA. It was not my project. I was just sitting in that office, but from talking in the coffee room with the people who worked on SKA, I knew what they were doing. Now, if they had an SBOM, that would have provided a very clear path of who's done what. But because they didn't use SBOMs, every time a developer would leave, get a job with Google or Amazon, a new person comes in, he doesn't know. He looks at the code, doesn't know where is the code being taken from, doesn't know what dependencies are connected. And even today, they still don't use SBOM because nobody went there, like in the US, to twist their hand to say, hey, you're gonna have to produce an SBOM. If they did start producing SBOMs, that problem with rotation of staff would have been eliminated because you would have transparency of who did what. and then you will be able to continue. Maybe it's going to take you 2 or 3 days to get up to speed, but you have visibility of who did what and where, from which open source repository was that code taken. Without an SBOM, it was completely useless. They would come, they would spend 2 months, they would just say, well, I have no idea what I'm doing. I'm not going to publish papers, my academic career is not going to progress, I'm not even going to be able to develop. Before they fire me, I'm just going to fuck off. That's what they did. And constant rotations of stuff. If they had an SBOM, that problem would have been solved. Now, the companies in the US that they were forced to start developing SBOMs, the Chinese companies that they were actually selling software to the feds, that they were forced to, to develop these SBOMs, if you ask them to stop, they're not going to stop now. Because they have seen how useful this tool is. Now, any other regulation that you might come across with, if somebody says stop with this, companies might be quite happy to stop with that regulation. With this one, no. Now, going to the next slide. So it was not triggered by the European Union AI Act. Actually, both of them, they work for the same purpose. Just that one of them is telling you do it, and the other one is telling you how to do it. Here I have some of these images and links. There's not enough time to cover them all. Okay, first Slido. If you can connect to Slido, let's open Slido. I'm not on this browser, I need to go to a different browser. Slido login. I'm gonna push that question. What is the primary regulator? This one. This is going to give me a chance to get a drink of water. That's all that it is. That's why I have Slido. So I can stop talking for a second and transfer the thing to you.
Professor, it's showing like voting is already closed.
Yeah, but
Sorry?
yeah, voting is the question. We just got the answers.
Ah, you got the answers. Okay, next question. Okay, so how about this one? Do you have this one now?
Yes.
I don't see any participants. I see 0 participants. That's why I'm gonna wait until I see at least one person joining. Then I know that you are. Ah, okay. Okay, so transparency. It's coming as the leading. Let's see who. Yeah, you're getting it. This is actually because this is very close to your field in the legal and admin. So this session you have been able to understand it much quicker than software developers, for example. Oh, you can't imagine. Trying to explain this to software developers is like pulling their teeth out. They just don't want to change the way they're doing. And once they adapt to this, then yeah, traceability, auditability, controllable, transparency, tracking the source, those are all solutions that you're going to have with the AIBOM there. Okay, so please do continue to use that. I will go back to the slides just to see what do we have next. And for this one, I'm going to zoom. Yeah, this it's an interesting slide now here. Those are links. You can click on the links when you get the slides, but you can also find that by typing in Google. CISA extends MITRE CVE Common Weakness Enumerator programs with last-minute contract. This was in April. So it was a very much last-minute extension. People take this for granted. Somebody has to pay. Common Weakness Enumerator, CVE, they cost money. And in the US, quite often, if something is not generating money back, this is capitalism, not generating money back, you scrap it. So I'm actually surprised that the US has been funding this program for so many years. And if you think, well, like they're being evil for not wanting to continue to pay, here's the question: why is the European Union not contributing to this effort? It needs to be a global effort. Everybody needs to contribute equally. India, Japan, everybody needs to pay a fee, and this needs to work. And that's what the Americans are getting upset about this. Other things that I wanted to point out that you might not be aware, many people in the UK are not aware, many people in the National Cybersecurity Centers are not aware. This is the person who actually runs most of SBOM and AIBOM. One individual. He's a PhD student like you. He's not paid by anybody to do anything. He's running his PhD, he has a part-time job. And as part of that part-time job, he's running all the efforts on SBOM, one individual, all the efforts on SBOM and AIBOM. So he has a part-time job with CISA, as the US Agency for Cybersecurity. And this is a picture from him posting on LinkedIn that he ended up in the hospital being overworked. Because sometimes you get so excited that the whole world is going to benefit from this AIBOM material, and you work, you don't get paid for that work, but you see how many people are using it in the world, and you get overexcited, and you end up in a hospital. That's one individual that is running that entire show. So before you start hating the Americans, remember you're hating one guy. Second guy here, he's my personal friend, Tomar Santos. He has done more for cybersecurity than many of these organizations, and we all admit that. So he runs, for example, the Red Hat Village on DEF CON. DEF CON is the largest hacking convention in the world. It happens in Vegas every August. So if you're in cybersecurity, if you're not attending DEF CON, you're basically not attending the most important conference in security. So he runs the Red Team Village over there. He also works for Cisco. He teaches for Pearson's and O'Reilly, and he's helping out with SBOM and AIBOMs. People have limitations, and what happened with CV, common vulnerabilities and exposure, which is another effort that came before. So CVE has to be assessed somehow. So the common vulnerabilities, and hold on, I have to show you this, otherwise. It's never did it, that thing still did it. Otherwise, you're not gonna have times common vulnerability scoring system. If you have a computer, please type what I'm typing on your device. CVSS, Common Vulnerability Scoring System, is the very first cybersecurity system that I worked on. I was much younger than I am today. I'm going to show you how to do it, I'm going to show you how to use it, I'm going to show you how to score vulnerabilities. By the end of the session, you're going to know how to score vulnerability. Now, click on this link, Common Vulnerability from FIRST. FIRST is the organization that has taken over the management of the Common Vulnerability Scoring System. Here you see you have many versions. The version I worked on version 1, 2, 3, 4, all of them. On 4, not so much. Not so much because I have other things to do. But let me know if you're getting to this. So what we did, we typed CVSS, Common Vulnerability Scoring System. You went to FIRST, then you're looking for the calculator. You want to open the calculator. It's a calculator, very easy thing. It's like a digital calculator. That's what you're gonna do. But you need to know what you're doing. Otherwise, when you open it in your own free time, you're gonna get lost. So let me know if one of you has reached this stage to click on this to open the calculator. Okay, one person has reached. That means that the instructions were clear. You see this form over here? That is the assessment of a vulnerability. This. It looks very confusing, right? Letters and numbers, you don't know what they mean. Actually, this was designed long time before 2026. It started in 1997. The very first version was published in 2003, 2004. It was made publicly available 2005. I don't know what year you guys were born, and I don't want to point the finger and ask for your date of birth, but is there somebody here in this room that was not even born in 1997? There's 3 people. This happened before you were born. So when you see these letters here, and you say, okay, this is very old. It is old.
Yeah, I panic.
But we have not changed the way that we assess vulnerabilities because it's good enough. And remind me because yesterday I was talking about building 1,000 AI agents, but there's something else. First thing you need to ask you, do you need them? Because you can secure them, you can assess them, you can analyze them, but do you need 1,000 AI agents? If you don't need them, if you can have a simple system, then that does the job. Why would you complicate your life? So this is it. It works. Can somebody decipher what those mean? You see, AV. Look at the screen, please. Please look at the screen. AV. So you're seeing the formula. You see what this very simple formula means. Basically, it's a map. That here is a map. AV stands for attack vector. So the first two letters, AV, the attack vector, is it network, adjacent, local, or physical? Since it's AV, 2 dots N, means that the attack vector for this specific assessment was the network. Then you move to the second, AC, AC here. So this is attack complexity. What is the attack complexity, low or high?
Low.
Attack complexity, oh, sorry, somebody said something, no?
No, just say low.
Sorry?
I just said slow.
Sorry?
I just said that.
You
it's
just
low.
said it's low, low, oh, yes. So those letters are basically, when you look at the entire calculator here, that is the map. That is how you map a vulnerability in 1997. Well, this actually became public 2005 later on, but it's a very old way of measuring vulnerabilities. It has not changed because it does the job. So the common vulnerability scoring system will produce a score based on that. So it will give you a numerical value. And when you go to common vulnerabilities here, those vulnerabilities, they would have a number. Let's see if I could open the vulnerability database. Okay, no, I won't be able to find it, but what I can do is this common vulnerability scoring system. And I'm sure that somebody from 1997 until today has pasted an image. There you are. So here, this is the one that I was looking for. Let's see if I can open it. This is from the CV 2.0, now we're at 4.0. I'm maximizing this. So, final point on the common vulnerability scoring system. I'm going to move on and I'm never going to speak about it again. So pay attention to this one now. If you're using the common vulnerability scoring system, which is here, once you click on this different task, you see the formula up there is changing. Every time you click something else, it's changing. And it will create a map that you can share with your counterparts in Australia, in other countries, in China. So you would say, this is how I have mapped this vulnerability. The mapping happens by simply clicking those buttons. And at the very end, you will get a score from that. And the score is going to look like this. This is going to be the score from 0 to 9, common vulnerability scoring system. 9 to 10, the highest risk. 0 to 1, the lowest risk. Trick question here before I close this browser. If it's the highest risk, which means it's the most potential for damage to your organization, means that if it's 9, 10, means this can destroy your organization. Your organization won't exist tomorrow. That's how bad that vulnerability is. So Google would suffer some catastrophic failure that people won't trust it anymore. Nobody's going to use Google anymore. Like it's going to publish all the messages that you sent since the beginning of time. That's how critical this vulnerability is. And that 0 to 1, it's something minimal that you might get away with. You might just pay the cost. It's not worth bothering with that. Do you think the priority is on 9, 10 or somewhere in the middle range? It's a question. Actually, you would know the answer if you think about it logically. This question is the same like in Oxford when you get a young student and on the interview they're all panicking, they're all sweating, they're all shaking. You ask them a simple question. If I put a gun on your head now and ask you to leave this room, are you leaving voluntarily or am I forcing you to leave? The answer is very simple. But because they're in a panic mode, they're not thinking straight. So this question is very simple here now. Would you be going for this 9, 10, the most severe, the most risky, or would you be going for somewhere in the middle? In the middle, exactly, in the middle, because that crucial vulnerability that might cripple your organization probably is not exploitable. There's a vulnerability scoring. It's very important that you distinguish between vulnerability scoring and exploitability scoring. There's a different VEX. VEX cyber. VEX. I'm trying to find cyberpunk VEX. I really don't like using in cyber. Everything is cyberpunk and everything is like this. Everything is very childish. I can't really find this, and it's just going to eat in too much time. I can explain what does it mean. When you have this vulnerability, that means it's the highest risk, but most often it's not exploitable. If a vulnerability is not exploitable, we don't really focus that much on it. We are building something called vulnerability exploitability exchange when we communicate with other organizations to say, okay, there's a vulnerability, but the exploitability is very low, nobody can actually exploit it, therefore we're not even patching it. Because if you patch every single vulnerability, your operating system might not operate as well as it should. So, do you think this Apple or Windows devices, they don't have vulnerabilities? They have many vulnerabilities that they're never being patched because they're not exploitable. Your devices are full of vulnerabilities. But some vulnerabilities from Windows are not applicable to Apple, for example. So am I going to worry about those vulnerabilities? I ignore them completely. There is a way of how that vulnerability can affect my system. It's so far remote that I'm risk managing it. So that 910 does not necessarily mean that your focus is over there. So I'm closing CVE. And we're going back to the slides. Here, going to the next slide. Oh no, let's look at the questions and answers from Slido. What did you have? Transparency, okay? So AIBOM material, the most important thing is transparency.
Sorry to interrupt. I would like to ask about the SBOM stuff.
Yes.
So I tried to upload several codes that I asked Gemini or ChatGPT to generate for me in the past. So normally the code is around 500 lines to 1,000 lines. And after using the detection for the SBOM, it actually shows that there's no dependencies found. Is that thing is good or not?
It's not very advanced code if there's no dependencies. One of the biggest problems that we have now is the software data poisoning, the supply chain data poisoning. Most of the code that you're developing, it has dependencies. If your code does not have any dependencies, it means that you just started building it today. Work on that code for 3 months, and then let's see if there's no dependencies. Actually, the code that you developed is very easy for me to check for vulnerabilities. That code, I can look at it, and just from looking at it, I can determine if there is vulnerabilities or not, because I've been doing this for many, many years. What I cannot check is code that you have developed for 2-3 months. Well, especially what they call the drunk code, because it looks like somebody was drunk and typing upside down. Software developers, they have their own, it's art, it's the art of coding, and not everybody follows the same path. And that code is difficult, and that's why we call it the drunk code, because you start a new job, you go there and you see 3 months worth of code from a good developer, not from somebody who doesn't know how to do it. He's developing the code in a way that only makes sense to him. And for you, it looks like he's been drunk when he was typing the code. It looks like he's typing things upside down, nothing makes sense. That code, it's when you start running SBOMs to see where the dependency is coming from. How did he build the connections? For the type of code that you refer to, I can look at that and tell you if there's vulnerability or not. Because if you work long enough, you know all the vulnerabilities. If you go to your GP sees you and knows if you have a cold or pneumonia or something. How? They know. Like, you go to your GP and you have a problem, within 5 minutes they know the solution. So within 5 minutes I can give you a solution to that code, but I cannot give you a solution to a code. It's not like in Matrix that you get a cybersecurity specialist and he look at the code, scans and detects everything. It's not like that. You need to have tools that would analyze the code for you. But that's why it's not important what you have over there, because you only did it 5 minutes ago. So, okay, moving on to the next one. Here is a link to what I found from the archive of the Joe Biden, the executive order. You can click on that link so I can open it. But I'm gonna open this one, the AIBOM initiative. Now it's skipping verification. Let me exit. But basically those are links, so I can just click on that and it will open them for me. I'm gonna open a few more. And I'm gonna show you the reports on SBOM and AIBOM. Let me exit from the PowerPoint slides. Safari, okay, here we are. From SBOM to AIBOM, this is from 2026. So you see, it's very recent that we are looking at this shift in software bill of material. Oh, I hope you didn't break your laptop. Is it alive? It's alive? It's okay. So we're shifting from SBOM to AIBOM. It's a new effort. It might take a little bit of time, but SBOM has become an official standard now. Everybody's using it. In the future, you can expect everybody to use AIBOM. The biggest initiative for AIBOM is from OWASP. In the course yesterday, I said that I'm going to talk about OWASP. I didn't get a chance to talk about OWASP, but you see things are building upon each other. So today we're going to be talking about OWASP. You can join their initiative here, and then you will get most up-to-date information. What can you tell me about this image here? That's a generative AI created image, right? You go to some very free version and you create an image and you upload it here. That tells you who is building this. They are not people who get really heavy salaries of 500,000 to work on this. This is a community effort. So the cybersecurity specialists are trying to build something. Actually, this is a very important point which I really need to talk, even if there's no time. When you build code in the future, when you are using social media in the future, how is that going to look? In the past, we used to have Instagram, right? Till 2-3 years ago, and people would take pictures of their lunch and everyone is watching that. They don't do that anymore. Then girls would take pictures of them doing this. They don't do that anymore. It's changed. The only people who post pictures of their coffee or on Instagram or of themselves are people who don't understand that social media has changed. Young people, younger than you, they look for communities on the internet. They are not looking for taking pictures. And you can observe the trend and you're going to find this. You can actually do a short search of how the trend is developing. Facebook is used by mostly old people now. Old people are looking at unicorns flying. Your grandmother, your mother is using Facebook. Young people don't use Facebook. They moved into groups and that they were closed, like WhatsApp, Telegram, Signal. That is also going out now. Some groups stay there, but they're shifting towards what it used to be in early 2000, like blogs, that you have a community group of common interests working together. I would encourage you really to start joining that kind of groups. It has value. If you get 300,000 people looking at your image in your bikini, what kind of value do you have from that? Do you get paid? Do you have anything? You don't have anything. But if you join a community group and you start using VS Code with agentic mode that I showed you yesterday with GitHub Education Copilot, which probably nobody found time to register, but if you go and register and you get that free Copilot, how would you start using it? Usually you have a community group. That is how we write code now. We have community groups and you set up a task and there are people who are interested in that specific, let's say AIBOM material. They could be from the United States, from Texas, from Montana, from Russia, doesn't matter. It's a community group that you have. And then you share information between each other. You share, let's say, how did you set up your agent? How did you change the agent in order to perform assessments for AIBOM material? Your teacher doesn't know how to do that. If you go and ask computer scientists, such solution does not exist. You can only develop it with community group. We're going back to the time when Satoshi Nakamoto was creating community groups and talking to people to find cryptographers who would enhance his database with cryptography to build Bitcoin. That is where we are now. So you would find a YouTube channel. Many people follow specific YouTube channels. Just make sure that you follow somebody who actually knows what he's talking about. So you would follow a YouTube channel that is working on developing a specific solution that you're interested in. You join that community group. It could be Discord, could be Slack. It doesn't matter. Actually, I have all the social media. So people are saying, oh, I only use, I don't care what kind of social media platform I use. I'm not connected. I'm not married to Reddit. I'm not married to WhatsApp. I don't have a relationship with social media platforms. I need to have a relationship with the community group because that community group benefits me. Now I can show you one community group that you could join. By the way, I don't know this guy. I've never met this guy. I'm not promoting this guy. I'm just gonna open my YouTube and you can see what I'm watching on my YouTube. And this is the guy, Nate Jones. So this is the YouTube guy that I watch. He doesn't show you any unicorns. There's no flying wings. There's no demos. He's just talking about what's happening in cyber world today. He also has Slack channels that you can join. And on that Slack channel, he'll set you up with a task. He will say, okay, use Zapier to create multi-agent system. How many of you have used Zapier? Raise your hand if you have used Zapier. One person has used Zapier. In this entire room, Zapier is the easiest way to get introduced to agentic mode. People ask me, how do I break into building AI agents? You tell them Zapier, they don't know what is that. So you need to have a community group that will support you in your development path with constant updates. Somebody who has actually committed his time to create this kind of videos that they talk about how to use agentic AI. Then they have their own community group on Discord, on Slack, and then you learn from the group. You have like a team of people that you work together on scientific problems that ChatGPT cannot find you the solution for. This is how social media is changing. This is how social media will look in the future. People will stop looking at unicorns. That's just temporary problem in TikTok. The same way that they stopped using Facebook for looking at the imaginary floods in Pakistan or the Indian curry cooking. Those are all not productive things. Social media will have a productive nature. So this is the person that I follow. Again, I'm going to close it. I'm not promoting it in any way. I don't know. Tomorrow he might turn out to be a criminal. I don't know. I just watch him on YouTube. Going back to the slides here, and AIBOM generator initiative, and this is one initiative here that you can join. This is the step that you need to perform to generate AI bill of material, the same like we generated SBOM. Now let me see how can I open this, because here it doesn't open. Oh, you can download it here if you want, but there's a web link. I'm sure that there's a web link. I don't want to download this. Let me look at the other slides just to find the link. Here, maybe this is the link. Okay. Yes, I have found the link. Let me close the slides and go back to where we were. We were here. Now. Okay, so AIBOM initiative, you see this here, it's like an image screenshot. It's not something that you can click. When you click, nothing happens. So I'm going to close that one. Here you have a SBOM for AI use cases. This, as you can see, 6 months old. That means that this community is not being properly maintained. If it's 6 months old, you need to have updates every day, not every 6 months. This is the White House release on agency AI use and procurement. I know many people said, what about this regulation? What about that regulation? Yes, there are loads of regulation. This is one. This is from the White House, but it's not really a regulation that explains to you how do you make agentic AI transparent. And we said that 10 minutes to, we're gonna stop with this. So we're gonna start with recovering, repeating, or what's the correct word? To check what we studied for the entire 5 sessions. That's what we're gonna do. We have 5 more minutes for this, and I need to show you how to build AI bill of material. So I'm closing these windows here. This is a paper that I wrote on how do you operationalize it, but I won't recommend that. What I would recommend is this. How do I send you this link? I need to send you this link somehow. This is not as easy to find, so I will, maybe I will send it to you and then you...
I can share.
Okay, so I'm gonna go into full mode because now you won't be able to see what I'm typing in my email. And maybe you can share it with them on WhatsApp so they can instantly open it.
Yeah.
Let me see. It's open source, it's not a virus, I promise. It's from Hugging Face. So I have sent that. Let me know when you get it. So I can close my email and go back. Basically, you're gonna open a link now and you're gonna save it in your favorites in the next few seconds. And then you're gonna play with it in your own free time.
Okay. I shared it.
You shared it, okay. So now that you have that, let me exit from my email so you don't read my emails. There's nothing fun in there. Here. So you're gonna be able to open this thing. I can explain how it works. I can explain what it does. I don't think it will do it justice to demonstrate it just quickly here because you need to learn how to do it yourself. So it explains here, enter a model on Hugging Face in a format. So you need to, we said we have 2.5 million models. How do you check, that was the question, how do you check if the model has vulnerabilities or what kind of data has been used? Enter a model on Hugging Face in the format. This is how you need to, you see the brackets, you need to format that within those brackets. And you just copy and paste from the 2.5 million models. Or you could copy the model URL and you can generate AIBOM in Cyclone DX format. Cyclone DX, there are like 2 or 3 organizations that they are working on this for a number of years. So the Cyclone DX is one of them. So you would get this as a hidden. Then you can browse all the models that are available in Hugging Face. And how do you find Hugging Face? In case you forgot, Hugging Face. There you are. Where do you find the models? Here. So here you have a whole set of models. You would open that model. Here you have the URL. So what is it asking you? The URL. Here you have the model URL, and you can paste it in here to generate AI bill of material. This is how you do it, and it's a difference between what you need to do and how do you need to do it. Regulations like GDPR, ISO, European Union Act are not designed to tell you how to be compliant. They're designed to tell you what you need to do. AI bill of material, SBOM are designed to show you the transparency. Now, here is the key question here. Is AI going to be compliant with the European Union Act? If you do this for your model, are you compliant with the European Union AI Act? 99% certainty that you will be. Has that been confirmed by the European Parliament? No. So this is the type of work that the European Parliament needs to hire computer scientists to check if this is sufficient. And they don't have the budget, they don't have the money, they don't have, you know the drill. It's always the same thing. We don't have the capacity to deal with that. We're going to tell you what you need to do. You need to do it, and if you make an error, you pay a penalty. But that's the wrong approach. This is what the Americans are criticizing. They're saying, we're not criticizing the European Union AI Act. We want to know how do we become compliant. What do I need to do to be compliant? And what steps do I need to take? And this is what they mean. You have tools that organizations like Microsoft can go there and just click a button and generate. I work for Oxford, but quite often my research is funded by organizations like Cisco or Google. And I'll tell you what, once they gave us a grant from Cisco, and I went all the way to the States because the academics are very much like the European Union. We only talk about problems. You attend an academic conference, it's problem after problem after problem after problem. No solutions to anything. You attend the industry conference, like DEF CON, Black Hat, they would start the conference by saying, we know what the problems are. We've been in this, some people have been doing this for 30 years. We know what the problems are. Let's talk about solutions. Let's not dwell only on the problems because that's not productive. So that is what industry usually thinks. That's the approach that they take. They want solutions. So when Cisco sent us a grant, I spoke with the big boss over there, the CISO, and I said, what do you want from this grant? At the end, you know, what kind of product do you want? A paper? He said, I want a button. I want to click a button and I want something to work. I don't care about your research papers. I want a button, like this button. This is what they want. He said, I'm busy, I have many things to do, I need to think about the paycheck, and when we build software, we need to sell that software. When we build networks, when we build firewalls, we need that to be, we need a button to check if this is compliant. If it's compliant, I need to sell it. That's what I want from you. I don't want you to write me a paper about 10,000 problems that I have. We know that there are problems. We want solutions. So 10 minutes left for this, and then we're going to have question and answer session. I'm closing this. You have the link. This link, you have it already. How do you find the models to play with it? There you are. Loads of models. There's 2 million models. Good luck to you when you test them all. We're going to need to automate this as well. In the same way that we have automated the CVE with the SIFT, how it's being scanned automatically, if I work only on this, within 6 months, I'm going to develop the solution. But it's not my job. I don't have funding to do that. So this needs to be funded by those regulators that they're creating the regulations. They need to allocate money for one software developer to build this solution. Why not have 10 software developers that will build this solution? If I'm not paid for this, I'm not doing it. And many people don't understand that concept. Many people struggle with this. I have people who eat breakfast for me in Oxford, and they say, "Oh, why are you going to hack me?" And I say, "Are you going to pay me? You know, I work for money. So why would I hack you? why do I care? What do you have on your phone? I really don't care. I don't even look at your Facebook profile. So why would I care what you have on your phone? If you want me to hack you, first you need to pay me. You know? So if you want me to build this solution, first you need to pay me. I work for money. I have to pay rent. So why am I not going to build this? Because nobody is paying me. Why is the solution non-existent? Because nobody has paid anybody to do this. That's the bottom line. That's the reason. Many people are doing this for free. And when you click these models, you don't pay for them. They're there for free. And regulators, they really need to cash in. They haven't cashed in. And this puts at disadvantage the industry. BMW, let's say they need to build the AI model to run their new electrical vehicle. Mercedes-Benz, they need to have electrical agentic AI vehicles. How do they make sure that they're compliant with the European Union AI Act? They have to pay a developer. That developer will develop a Mercedes-Benz specific solution, and BMW will develop BMW proprietary solution. Nobody knows if this is what the European Union wants. Why? Because the European Union doesn't know what they want. They want transparency, but they're not developers, they're regulators. Now, closing this, you have all the information to play in your own free time. In this slide, we have more sliders, so let's go to the next one. Let's start on a scale from 1 to 1, the lowest, 5 critical. How critical is AIBOM style documentation for demonstrating compliance with the European AI Act Articles 11 and 12? You should know the answer because we covered it, but although I didn't mention specifically 11 and 12. Ten people, 11 people have voted. Just gonna wait for a few more people to vote, and we'll discuss it for 10 seconds. Move on. We have loads of questions, and then we'll cover the slides from previous courses. I'm just gonna open them and point out what did we study. 17 people. I think we're reaching the point that it's enough, that we have 65% already understand that AI bill of material style of document is compulsory for compliance. Now, a follow-up question on this. Has the European Union confirmed that they're happy? Have they confirmed that they're happy with AI bill? No, there's no confirmation. But from the description that they have provided of what they want, AI bill of material will do 99% of what they require. They need to confirm. People can be very challenging. I mean, I work with the Turing Institute. I'll tell you an example that I published 3 papers. That was the topic that we agreed at the beginning when I started. Halfway through the project, one of those very high professors changes his mind. He says, I don't want those topics, I want a different topic. So my question here is like, this person, did he actually send me an email to confirm this specific topic? No. So I said, okay, let's change the topic. Send me an email confirming the new topic. I want that in an email. He cannot write the email. He doesn't know how to define the topic in his mind. He says, but I want this to be connected to social scientists. I want this to influence the impact of cyber security specialists, but from a social scientist perspective. And my question is, define the topic. Silence. And they get angry. They get angry when you try to poke them. But you have to poke them. Because if they don't confirm that this is the exact topic, 3-4 months later, they might say, oh no, that's not what I wanted. So when you poke the European Union and say, is the AI bill of material with these specific components, with this specific structure, with this explained in the research paper, is this going to be satisfactory for you? They are not capable of confirming that. Why? Because they have not defined the risks, first of all. So they need to have specialists over there who would define the risk. And common vulnerability scoring system, is that relevant to AI security? No. So for AI security, you need to look at, and I think we did cover this, MITRE Atlas is for AI specifically. MITRE Attack. MITRE Attack. This framework is from the same organization, from the same company, but this is for IT, not for AI. MITRE Atlas is for AI. So CVE is not, a Common Vulnerability Scoring System is not for AI specifically. Okay, moving on to the next question. Rank the following AI supply chain artifacts by importance for legal and legal assurance. Oh, I really hate that word. Assurance, I hate it so much. Assurance as a word should not exist. You need to have either compliance or risk management. What is assurance? I'm assuring you that, you know, something is not going to happen, but I'm not sure that that I can assure you. First of all, risk management refers to an established approach that you're risk managing. And if you cannot risk manage something, how do you mitigate that? Insurance. You pay insurance. Assurance, it's a version in between that you cannot risk manage and you don't want to pay the money for insurance. So the assurance is basically somebody who maybe has a degree in English literature and it's reading a paper about cybersecurity and trying to assure you that this is possible. And quite often, cybersecurity specialists, they would not work in assurance because it's vague. It's too vague. And then I can take the blame for not being able to assure you of something that I cannot assure you about. Risk management is a very ticking boxes exercise. Let's say when you fill in your form for traveling abroad here, you have to fill in a risk management form. What does it say? Are you going to travel to a country that is on the terrorist list? If you click yes, boom, you're not allowed to travel. If you say no, continue to the next step. Are you going to engage in any activities that include drugs, recreational, alcohol, yada yada yada? If you click next, risk management is not, then you have to say no. That is risk management, it's very specific. Assurance is vague, and I really hate assurance. Rank the following AI supply chain artifacts. Legal assurance. Yeah, I mean, this is subjective. This can be subjective. So let me show you the answers that I have prepared here, and then I've checked them. But this, keep in mind that these are generative AI populated answers, and they are not necessarily 100% correct. I can only check the technical aspect. The legal aspect, that's your domain. So rank the following AI supply chain artifacts by importance for legal and assurance. Let me find this. Rank the following AI supply chain. Databases, models, feature pipelines, deployment, inference, dependencies. This is the expected for discussions. So that is databases, models, feature pipelines. That's what makes sense to me. Databases, models, feature pipelines, pre-trained models, sources. This is very vague. Training and fine-tuning datasets in terms of AI, what AI algorithm they use. Now, somebody asked me yesterday, you sir, you asked me to list all the different AI models, didn't you? Do you remember that question? Somebody asked me to list all the different foundational AI models. I do have a slide for that. Let me show you. It's only going to take like 1 minute. Free form. It's not going to be one. It's not going to be two. It's not going to be done. He's got his pen and paper. Sir, if you want to write this down, good luck to you. We're going to be here for an hour. It's not just one. Let me just find the file. Okay. I'll tell you how I created this list. I created this list because I teach with Pearson's and O'Reilly. So tonight, for example, I have a course with Pearson's and O'Reilly again. And on one of the courses, I had an idea that I'm going to list all the different algorithms and I'm going to include one sentence explanation. Just one sentence explaining what that model does. That's going to take like half of the 2 hours. That's going to take just one sentence is going to take 2 hours. Look how many there are. Red means a different category. That's how I categorize them. Blue means similar models within one category. So let's go very quickly because this was a question that one of you guys asked me. We said that there are supervised learning algorithms. I explained this with labels on apples and pears. When you have an apple, you put a label, this is an apple. The machine learns that this, so those are supervised learning algorithms. We have linear models, linear regression, logistic regression, support vector machines. Then we have decision trees. You know what's a decision tree, right? It's a very simple statistical model, yes or no. If it's a yes, you go that path. It's no. It's a very simple decision-making algorithm. Ensemble methods, random forest. What is a random forest? Many decision trees. So it's a whole forest of decision trees. Neural networks, K nearest neighbor. This is a very easy algorithm, but very effective. So you have a data plot. And what are the three nearest dots to this? Naive Bayes, discrimination, analysis. Now, that is just for unsupervised. Here we have a list of, that's just for the supervised. Now we have a list of unsupervised clustering, dimension reduction, so principal component analysis. It's a very popular algorithm. Association rules like a priori, F growth. Then there's a third category which I don't really teach because I think this third category is very, this is semi-supervised learning algorithms. And the fourth category, which in my teaching is the third category, reinforcement learning. Now, how many reinforcement learning algorithms? I specialize in reinforcement learning. That's my area, reinforcement learning, because I think it has the most potential. Pure learning is the most promising algorithm. What was reinforcement learning used in the past before this AI advancement? Video games. It was used mostly for video games, reinforcement learning. And you see how many different algorithms they belong, apart from Q learning, specific to that category. Then you have deep learning. That would drive me mad. If I worked here permanent basis, I would unplug that. Every time I would go in, I would first unplug it, then I'll plug it back in. You see there's more and more and more and more Bayesian methods. This is what we teach in Oxford. Actually, one of the main engineering subjects on artificial intelligence is based on Bayesian methods. This is one of the core modules. We don't teach all this. Nobody teaches. No university is teaching all this. So it's no way that you're gonna know how to apply every single algorithm. Bayesian methods is very difficult subject for many students to understand. Just that one. Now imagine you multiply that times 10. They're not going to be able to learn. So this is a list of all the different AI models. So I hope, sir, you're satisfied with that answer. Next question. This is an active poll. What would you consider the strongest piece of evidence to defend an AI system in court or before a regulator? One person typing, just one person typing. Two people are typing, okay? AIBOM, ISO, okay. Nothing. Yeah, this is interesting. We only have 10 minutes left of this session, so I'm gonna start talking. Only 6 people responded, just to make sure we can progress to the final ones. As I said, I have to finish on time. I have another session after this one. All the answers are correct. My personal opinion, nothing. Nothing is credible. Why? Because AI bill of materials is not approved. If they don't approve that this is a credible validation mechanism, then how can you say that that's legally defensible? ISO does not have a specific regulation for making AI transparent. They're building at least 10, 15 different standards. None of them is on AI transparency and none of them is implementable. Remember the click of a button? That does not exist with ISO. First of all, they don't have a formal standards yet, they're working on them. Second of all, even when they develop them, they will tell you what you need to do, not how. And then they'll say, oh, you're computer science, you go and figure it out. I don't know what you mean. I cannot read your mind. You have to define that very clearly, the parameters, everything, and that needs to be actionable. If what you desire is not actionable, it's the same like saying you go to the moon. You're not being clear. There's no clarity. Okay, next. Join the quiz. Now this is the quiz time. We have 5 questions, 20 seconds each. Okay, 16 people, 18 people. We're doing fine. Okay, I can start the quiz then. What's the primary purpose of an SBOM in an AI system? It's a tricky question. Because it's not an AI bomb, it's an SBOM in an AI system. I don't expect that you guys are gonna have the answer for all these questions. So now it's thinking. Enable component level risk traceability. That's the correct answer. And 74% of you got it. But yay, you understand the subject. Next question, how does AIBOM differ fundamentally from an SBOM? How are they different fundamentally? They're both about software. What is the difference? Five seconds left. Okay, it's thinking. Most of you selected C, and C is the correct answer. Now, next question, which ISO standards provides the governance framework that AIBOM material evidence plugs into it? This is very much work in progress. So if you get it wrong, don't worry, because AIBOM should plug into at least two of those, at least in 2, and it's not. Yeah, so most of them ISO 42001. Yes, there you are. But it should also plug into ISO 27001 because that's the cybersecurity standard in the future. But 42001 is specific to AI. What are the next question? What are the inference layers attacks particularly problematic legally? Yeah, 88% got it right. They can extract personal or confidential data without a formal breach. Question 5 out of 5. The AI system that complies at deployment time remains compliant throughout its life cycle. True or false? Answer, it's as simple as the question about putting a gun on your head and asking you to leave. Maybe you're getting confused. Too much information. This is a very simple question. And 80% got it correct. It's false. So you deploy a system at runtime, doesn't mean that it's going to be compliant in the future. Now, we're wrapping up this course. I'm closing the slide of slides. I'm slowly closing everything. So here you have, hopefully you know how to do the SBOMs and how to do the AI bombs. I didn't really share this link with you because I showed you how to do it. If you forget, the video will be online. You will be able to rewatch the video. Now, just going through the folder of what we've done, we have 5 minutes in total. 5 minutes, that means 1 minute per course. So the first course, we looked at AI security foundations, specifically for law and business. On this one, I told you 3 categories of attacks, although I did explain there is more categories of attacks. Actually, tonight, I teach the top 10 categories of attacks. Let me show you that just in case you think this is final. So before you start thinking, this guy told me that there are 3 types of attacks and there's only 3 types of attacks, there's no more than. So tonight, this is tonight, 27th of January, I'm teaching the top 10 categories of attacks. Now, when I said top 3 categories, I've tried to put them in some kind of a framework that would make sense to people to understand in 1 hour. But there are more categories. So 3 types: evasion, poisoning, and extraction. Evasion is when you confuse the algorithm. Poisoning is again when you confuse the algorithm. Extraction is when you steal the algorithm. So that was the first part. Another point that we made here is that you need to be compliant with multiple regulations, and you can be compliant with multiple regulations in the same time. Why are people so religiously focused to one regulation? They've learned that ISO standard and that's all they know. With time, let's say somebody is 18 years old, how much time has he had in life to learn all these different standards? If you are 35 years old, you had more time to learn these standards. Therefore, you should be able to do, the longer you stay in security, the easier it's going to become to show compliance in the form of a table like this. Black Mamba, I showed you polymorphic malware that changes using AI. Black Mamba is a proof of concept malware, keylogger that steals your credentials. Morris Worm from 1988 has been adapted to a different type of worm using generative AI. You can repeat that for many of the exploits, and Shai Hulund is a supply chain attack. That is a very problematic now. Everybody is worried about data poisoning supply chains. So I'm closing this one. We covered that one, first one. Let's go to the second one. I'm timing it to the minute, so if it's more than a minute, I have to change it. So hold on, let me find the actual with load. Okay, so this is with load. In the post-quantum security, we said that some data needs to be secured, not all data needs to be secured. Post-quantum cryptography is only applicable to specific data. You got it wrong. You thought it was about your personal data. I corrected you, I challenged you. I do apologize. When I see something that you get terribly wrong, I really have to challenge you. It's not about your personal data. It's about security, it's about money. It's about those Bitcoin wallets that you can extract all the money. It's about shares, bond prices, it's about value, it's about secrets. It's not about your personal secrets, it's about secrets that you can monetize. So that was the post-quantum security, and here I don't see anything of significant value except the timeline. That we looked at this timeline, and the timeline would tell you that, hold on, that's wrong now. The timeline, if you look at the timeline, it will tell you that although some of the development of post-quantum cryptography is not going to start, let's say in the UK it won't start until 2028. According to IBM, the first demonstration of quantum advantage would happen by the end of this year. So the UK is not even going to start implementing post-quantum cryptography by 2028. They understand the risk of store now, decrypt later, just they're not taking it seriously. What is the solution for your organization to adapt to this instantly? You use cloud providers that they actually have post-quantum cryptography. And I think I did show you the NordVPN here, but if you go to NordVPN, somewhere here, settings, you see, I just need to click this. I need to tick, yeah. Oh, it's not showing. Of course it's not showing. NordVPN. You see, this is my NordVPN settings. I just need to click that button over there and I'm gonna have post-quantum encryption. So if your organization does not have capacity to handle this, you need to change your cloud provider, that's all. You just need to change your cloud provider. If your VPN provider does not have that, 12, 15. So we are running out of time. We did cover the SBOM in clear, the blockchain technology. Here, the key point that I made is an old technology. Even Satoshi Nakamoto, when he developed it, he got disappointed with it. He wanted it to be virtual machine. Community objected. They wanted Bitcoin to be store of value, gold, and he left the project. So this is a very old technology. Don't throw your money into this. Civil attacks are the biggest problem in blockchains. And the final, agentic AI behavior. What is the biggest risk in agentic AI and how is it different from current types of AI? Well, it's autonomy. It's autonomous. It makes decisions the same like going with your boyfriend or with your girlfriend, asking her to drive the bike. Do you trust? Does that person know how to drive a bike? What if it's the bike itself driving? Can you trust the bike? Now that is the end. We're gonna have to end this session, and I hope you have a good lunch. I'm gonna stay here, and I will run my next session in the next 15 minutes. So 12:15. This is the end. You have a break until 13:30. If you do want to connect in the future, easiest way is to type my name in the internet. You're gonna find my Oxford University staff profile, and here you're gonna find loads of ways how you can contact me. Those are all my different connection mechanisms.